Hello, this is Dr. Hasan Abdullah with the course Introduction to Natural Language Processing. The topic which we are covering is text pre-processing, and this is the second lecture of this topic. So this is the course contents. As you can see, there are quite a few topics here, and this is the topic which we are covering. So very briefly about the supplemental website for this course, which is ezmcq.com/goget. This is basically a learning management system. It has many features for personalized learning and customized learning experience. So these are the videos which cover these features. So I would suggest you to look at these videos to get the most benefit out of this tool and out of this course. So you can see we have quite a few courses here, core computer science courses, and we have artificial intelligence and machine learning also. So we focus to the course of our interest, this is natural language processing, and we go to the text pre-processing, and we have already covered the first 10 question and answer. So we go on to the 11th question and answer. So what role does text normalization play in pre-processing? What is the significance of text normalization? So it is used for handling the numbers, and the numbers may be written in a different format, so it need to be unified. And handling the dates also, there are so many different ways of writing the dates. It has to be consistent. Converting to lowercase, for example, apple with a capital A versus apple with a lowercase a, and handling abbreviations. Abbreviations, for example, didn't to did not. Okay, so all of these things have a lot of significance, as we'll see towards the part of the course where we look at the applications. So if you're interested, there are the references. So what are the challenges of text pre-processing for different languages? Now, this text pre-processing is not limited to English also, because different languages have their own morphological richnesses, of course. And of course, for example, if you look at word segmentation, in English language, it is based upon space, but in other languages, as we'll see, there may not be a space. So that segmentation is not that simple. And ambiguity in the word meaning, how very, very subtle changes bring about ambiguity in the meaning of the word. And handling diacritics, I'll explain it to you. Complex syntax, the syntax may be very different and very complex as compared to the English language. Language specific stop words. Stop words are in English like is, the, and so on. But these stop words may be very, very different for different languages, of course. Word collocation and idiomatic expressions, for example, hitting the bucket. Now, hitting the bucket in literal meaning has a different meaning as compared to the idiomatic meaning. Script and encoding variability, I will talk about it, and lack of resources. So let's go over the detail instead of looking at the bullets. So morphological richness for in Finnish language, in Hungarian language, for example, you can see that there are the very, very and kick the bucket. I've already spoken with you. And non-Latin scripts may require specific pre-processing steps, which are very different from English. Lack of resources, lack large annotated corpora, lexicons. Okay, there are quite a few for English language, but for other resource-rich languages, those resources may not be there. Pronouns and genders, gender-related languages, Spanish, French, and German require special handling for pronouns, which are gender-specific. Okay, and it is not there. Gendered languages like Spanish, French, and German, in which the pronouns have the gender associated with them. They are gender specific, and that needs to be taken into consideration during text pre-processing. And these are not those the only gendered languages, there are other also. So how do you handle non-standard text? Because the non-standard text is everywhere in social media posts, slangs and emojis, and everybody comes up with their own way of expressing themselves. So there's a big issue in text normalization. So let's go on to the detail instead of just looking at the bullets here. So text normalization, for example, LOL, converting it to laughing out loud because of the consistency also, and then converting the keywords example to this to into a happy, and some things which may deemed irrelevant for the analysis, they need to be removed. And for example, in sentiment analysis, certain emojis, if they are characters, if they remove, they have strong cues for the emotional part, for emotional sentiment, so that could be a loss also. Dealing with hashtags, hashtag AI rocks, okay, processed by removing the hashtag symbol and separating them, and then ensuring that the meaning is also preserved. handling mentions and so on. Tokenization recognize the symbols. Okay, it depends upon it's a unigram or a bigram, and how to prevent loss of important context, and how not to increase the complexity of the problem. And then there are the slang and information informal language handling. For example, gonna and wanna need to be expanded into their formal counterparts, okay, or treated as specialized lexicon. So it's up to those decisions. Spelling corrections, how the spelling corrections are going to be done, or there has to be context aware spell checkers. Basically, we look at the context in which a word is used, and based upon that, correct the spelling, or based upon this Levenstian distance, find out how the words are different and which would be the correct spelling. And then you have pre-trained language models, and of course then there are sentiment analysis considerations for non-standard text, which are in tweets and social media, and which are domain specific also. So what is the impact of text pre-processing on performance of NLP model? Why we should be spending time and resources on text pre-processing? What are the benefits of text pre-processing? Is noise reduction. So when the noise is reduced, the quality of the results improve. For example, all of this work is done to achieve certain applications of natural language processing. It could be text generation, it could be audio generation, it could be speech recognition, and so on. So reducing the noise improves the quality of the results. Then improved tokenization. When noise is reduced, when we are doing tokenization, the quality of the tokenization improves because it does not takes into consideration the noise. And as I said, for normalization part, consistency in the vocabulary. Of course, it has its downsides also. Handling the ambiguity, reduction in dimensionality, because are reducing the the noise. Let's go into detail. Okay, let's go into detail instead of spending time here. Pre-processing techniques like stemming and lemmatization and stop word removal result into more consistent vocabulary, focusing on the important contents rather than the redundant or uninformative words. Okay, this normalization basically corrects the spellings also, and learning of the model becomes more accurate. And by reducing the dimensionality, such as feature extraction, stop word removal, so basically the complexity of the problem is reduced. The variability in the text is reduced. So that results in reducing the dimensionality of the input text. And when the dimensions are reduced, we go away from the curse of dimensionality, and that results in improvement in the computational efficiency. Okay, and for example, in the context of sentiment analysis, when we remove the informal language slangs and omicons, and pre-processing can help the sentiment analysis model better, okay, and interpret the nuances better and generate better results, leading to more accurate predictions. Impact on downstream tasks. Whatever is this is done, that is ultimately going to affect the next stages. For example, named entity recognition. What is the person? What is the place? What is the date and part of speech tagging? Which is the noun? Which is a verb? Which is a pronoun, adverb, and so on. And machine translation. So it has a great impact. Okay, and then of course for models which are trained on specific domains, domain specific pre-processing has to be done. For example, hashtags for a legal or for medical profession and so on. So it is very critical. Now when we are doing this pre-processing, what are we gaining and what we are losing? So what are the trade-offs between different pre-processing techniques? So let's look at the details of those. For example, stop word removal. When we remove the stop words like and the and so on, of course we reduce the dimensionality by removing the irrelevant words. But in the context of sentiment analysis, these stop words can carry important meaning. That is covered in the last topic of this course. Stemming versus lemmatization. Of course, it reduces the root to its or it reduces the words to their root. Okay, and that results in generalization. But like doing it extensively, better becomes bet. Well, bet is a dictionary word, but bet may not be relevant in the context where better was used or in the sentence where better was used. So this may result in loss of semantics or the meanings. And then is lemmatization. It results in accurate and more valid words, but it requires a lot of computational resources. And if it's a dictionary based approach, a rule based approach, it has its own issues. And lower casing, of course, this is consistency, reduces the dimension, replacing the capital A in Apple with the lower case. But of course, but it generates problems, havoc in named entity recognition, because one is a company, other is a fruit. So so there are significant issues to be taken into consideration. Then is tokenization. We break into small parts or tokens, but that may result in incorrect splitting in the language. Okay. So for example, if you break New York into new and York, that does not carry a lot of meaning. Removing the punctuations, apostrophes, and exclamation marks and so on, which describe the sentiment, you remove them and you don't gain much other than normalization or standardization. And then text normalization of non-standard forms. Okay, of course, it ensures formal language effectively, but the context is gone. Okay, the keyword is the emotional impact is gone, and the n-grams and the HTMLs and the URLs and all those things, spell correction. Okay, of course, it improves accuracy in the downstream tasks, but overcorrection can lead to loss of intended meaning or context. And handling numbers and dates. So there is a lot to be learned and a lot to be looked into carefully. So let's move on to the next set of Q&As. How does text preprocessing contribute to the computational efficiency in the NLP pipelines? So now we're looking at the computational efficiency. Of course, as we mentioned that this normalization basically, which is part of pre-processing, results in the reduction of dimensions. So when the dimension are reduced, of course, the problem complexity is reduced. We don't fall prey to the curse of dimensionality. And then is the noise reduction. When the noise is reduced, the quality of the results increases. Standardization also leads to better quality results. Tokenization gets better, reducing data size. So the space complexity is also reduced and facilitating parallel processing. So let's look at how does it facilitates parallel processing. Pre-processed text can be more easily split into smaller chunks as compared to larger chunks, and so that improves the scalability and the speed of the NLP tasks. So that's how it helps.